Okay, what should I do? What should I do? Well, I noticed that if I take the derivative of 1, like if I said this was my u, I divide by 2, you see my x's wouldn't cancel out, right? And if I said, I don't know, if I said that this was my u, if I divided by cosine x, this x wouldn't cancel out. So there's not a derivative sitting next to my u. So what I noticed is this is going to be what type of problem? An ET problem. It's going to be an integration by parts problem, okay? And ET is in order because it's in the order of like bit, all right? So what that means is this is my u and this is my dv. Okay, so let's go ahead and get started on that. If u is equal to e to the 2x, dv would be sine x dx. What's the derivative of u dv? Good, 2e to the 2x, and I'll try not to forget my dx. So 2e to the 2x dx. All right, what about the antiderivative of sine x? I know the antiderivative of dv is v. What's the antiderivative of sine x? Negative cosine x. All right, I'm ready to go. The integral of u dv is equal to uv minus v do. Do you have it memorized by now? Okay, hopefully you do. And so what we're going to do is we're going to multiply u and v together. Okay, so that's going to be u times v is negative e to the 2x cosine x minus v du. And it really always turns out you multiply these two together and then you multiply these two together. So v times du is 2e2x cosine, oh, I forgot the negative. Let me write it again, sorry. Negative 2e2x cosine x dx. Guys with me so far? So this is the answer. This is the answer to the integral of e2x sine x dx. It is this right here. But the problem is I have another integral. Okay, so let me see if I can solve this integral. It's negative, negative, so you guys okay if I do make a positive. Okay, and I relook at this, and as I look at it closer, I see that what do I have again? An ET problem again. Okay, well, let's do it again. If I have an ET problem again, I'm going to do my crosshairs. Okay, u is equal to, this time, u is equal to 2e2x, and dv is equal to cosine x dx now. On the left side, I take the derivative. What's the derivative of 2e2x? 4e2x dx. Okay, and remember, where did this dx come from? It was just down here, and I multiplied both sides by dx, so that's where the dx came from. All right, let's do the right side. The right side, I take the antiderivative. What is the antiderivative of, let's see, dv? That's v. All right, what's the antiderivative of cosine x? Sine x, negative or not? Anti, no. So this would just be sine x. Okay, so let's go ahead and put this in the formula. So this is saying that the integral of e2x sine x dx is equal to negative e2x cosine x plus what? Plus this brand new uv minus v do. Okay, and this new uv minus v do was found by these crosshairs over here. So let's go ahead and multiply the u times v. What I get there is 2e2x sine x minus the integral of the diagonals here. So that's 4e2x sine x dx. See if I wrote that right. That was a lot to write. Okay, is everybody with me so far? All right. And so remember, my goal is to solve for the integral of e2x sine x. Okay, but what I notice is down here, when I have to get this integral looks just like this integral right here. So if I do another, crosshairs here, I'm just going to go in circles. It's going to be an endless, infinite circle. Okay, that's what some of you guys did on your quiz. Okay, an endless, not on this problem, but endless circle. So what am I going to do now? Any ideas? Well, yeah, move this over. Remember, all the ET problems, you got to take ET home. Okay, and the way I take them home is, this is really hard to see, but I'm going to pull out the 4 scalar. And this makes it a lot easier to see. What I see is this part right here looks exactly like this part. Okay, which means if at this point on, it's no longer calculus. You guys agree with that? It's no longer calculus. I mean, I know I've got an integral sign there. It's no longer calculus. This is just an algebra problem. Okay, I've got 4 of these on this side. I've got 1 of these on this side. Okay, if I add 4 of these to both sides, Okay, it's just really 4 times some variable. What do I have on the left side now? 5 of them, right? So now on the left side, I have 5 of these, okay? Still, this first term, negative e2x cosine x, that just carries down. We don't do anything with that term. This 2e, actually, there's nothing to do with that either. That one's done, okay? Minus 4 plus 4 is what? 0. So I'm done, okay? And so remember, the goal was to solve for this e2x sine x dx. So if I wanted to solve for this, what do I have to do to both sides? Divide by 5. And make sure you divide the whole thing by 5, okay? And don't forget Charlie, and that is your answer, okay? And I want to say on the test, I get a lot of good stuff. Like this part right here, the hard part, I get students coming down to this part, and then they're just stuck. And then they do all sorts of crazy things after this, okay? But from here on out, if you can see that it's just algebra, then you're in good shape. All right, let's do another problem. I know that took up a lot of room. Let's do another problem, okay? And I want to point out that this is a very common mistake, this problem here. Because as you're doing the test, you'll be like, oh, I just did an ET problem, and now what do I have? I have a PT problem, right? Okay, and if you see that this is a PT problem, you'll go, oh, I'm even happier. That means it's just a table trick, okay? So on the left side, I take the derivative all the way down. On the right side, I take the antiderivative, okay? And the antiderivative of cosine, oh, that's so easy. That's just sine u divided by the derivative of my u, and then that's just cosine u divided by the derivative of my u. Gosh, I don't even know what the derivative of this is. 9x4. Okay. Then it's sine u divided by the derivative of my u. I'm actually kind of confused right now, too. Okay. And wow, plus, minus, line, line, line. That was so easy. Okay. What did I do wrong? It's not an integration by parts problem, but why not? It's a PT problem. And I took the derivative and I took the antiderivative. Yes, over here, the integral of cosine x cubed plus 1, okay? When I disengage it from this x squared, okay, the rule is it's the integral of cosine, which is sine, divided by the derivative of your u, which is 3x squared. And you always have to check, did my x's cancel out? Did they cancel out here? No. That means it is not a possible integration. Like, I just made up this integration, basically. It was not a possible integration, okay? So back to the drawing board. The table trick didn't work because the integration was impossible. And we'll talk later on. We're going to do a lot of integration now. We'll talk about later on when the integration is impossible, what do we do? And that's when Taylor series comes in, okay? Taylor series, instead of like trying to figure out the integration, we're just going to estimate the integration, okay? And that's a few units down. All right, so here what you do is this, if you remember it. What is the integral of cosine u? Sine u, right? But don't forget to divide by the derivative of your u. Well, if this is your u, what's the derivative of x cubed plus 1? 3x squared. Do my x's cancel out? Yes, but I actually have what left over? 1/3, okay? And there is your answer, okay? That was pattern recognition. Some of you guys may not have been comfortable with pattern recognition, okay? If you're not comfortable with pattern recognition, you could also do u substitution, okay? And so let me show you u substitution. So this would be your u. The derivative of u is what? X squared. You solve for dx, okay? You substitute two things. You substitute your u and you substitute your dx. So this becomes x squared cosine u times du over 3x squared. Do my x's cancel out? Yes, okay? And so what you have left is the 1/3, which is what I have here, the integral of sine of cosine u, which is sine u. You guys see that? So you end up with the same thing with u substitution. Either way is okay, but today I'm going to talk about, I really want you to do pattern recognition with cosine if you can, for two reasons. One is because your paper won't be so messy. You'll be less likely to make, your paper won't take up as much room. The second reason is because on the BC test, on AP exams, you need to go fast, okay? It has more content, okay, than the AB exam. You need to go fast. And if you can do pattern recognition on different problems, it'll help you. And the cosine sign is one of those that you'll see over and over again. So we'll talk about today how to do pattern recognition. Okay, well, let's look at number 12, and then we'll go to number 3. Number 12 was the ln of x squared plus 1. Okay, guys, I need to stop and just make sure that you guys understand this. Whenever you have an ln x inside an integral, it doesn't matter what the exponent is, no matter what the exponent is, okay? If you have a 1 over x sitting next to it, this will be a u sub problem. Why? Because what's the derivative of ln of x? 1 over x. It's going to always divide out, okay? Anytime you have anything else next to it, whether it's just an x or nothing, okay, it's going to turn into an integration by parts, all right? So just letting you know, this is the only one that's a u sub. And you can also see this sometimes like that, right? I mean, that's the same problem, okay? All right, this problem is going to be integration by parts. This is going to be my u, and this is going to be my dv. So my u is equal to ln of x squared plus 1, and my dv is equal to dx. What's the derivative of an ln problem? What's the derivative of ln u? U prime over u, right? So this guy's, yeah, go ahead and pass up your warm-ups, guys, if you haven't already. So this guy's over here is going to be u prime over u. Well, that's going to be 2x over x squared plus 1. Do you agree? Okay. So this is going to have a dx here because I'm going to multiply both sides by dx. Okay. Carl, are you looking at this one? Yeah. Okay. So guys, on this side, I'm going to take the integral. So the integral of dv is just v, and the integral of dx is just x. You guys good with that? Okay. So now I'm going to rewrite this problem. So this is going to be u, the integral of u dv, which I defined right here with my ln of x squared plus 1 dx, is equal to u times v. So I multiply these two together, so that's going to be x ln of x squared plus 1 minus the integral of v du. So we multiply these together, so this is going to be 2x squared over x squared plus 1 dx. So make sure you understand what I just did. This is u times v minus v du. I just memorized that formula, okay? And so this is the answer. The answer to this integral is this part right here, but what you have to do is get rid of all the integrals. So any ideas how to get rid of something with a 2 exponent on the top and a 2 exponent on the bottom? You're going to have to log divide. Okay, do you see that? If the powers are the same, or if the power on top is bigger, you have to long divide. So when I long divide this, okay, x squared times what is 2x squared? 2. 2 times x squared plus 1 is 2x squared plus 2. I'm going to subtract. 2x squared minus 2x squared is 0. Do you see that this is really 0 minus 2, which is negative 2? Okay, so what I get here is plus negative 2 over x squared plus 1. So my answer here is going to be equals x ln of x squared plus 1 minus the integral of 2 minus 2 over x squared plus 1 dx. Is everybody good so far? All I did was rewrite what 2x squared over x squared plus 1 is. All right, I'm going to erase my long divide. All right, if I do this, be careful though, this negative, see this negative? It's a negative of this entire integral. So you need to distribute this negative through. So this answer is going to be x ln of x squared plus 1 times negative integral of 2 dx plus the integral of 2 over x squared plus 1 dx. Okay? What I did was I distributed this negative, and remember, this is a buy one, get one free problem. There are actually 2 problems I had to do here. I thought I got to do just one, but oh boy, I got to do 2. Okay, what a privilege. All right, so what I'm going to do is I actually know the integral of negative 2. What's the integral of negative 2? 2x. So this will be x ln x squared plus 1 negative 2x. What's the integral of 2 over x squared plus 1? Yeah, it's an arctan problem, okay? So this would be u squared is equal to x squared. A is equal to 1. A squared is equal to 1. That means u is equal to x. A is equal to 1. Du dx is equal to 1. Dx is equal to du. I substitute 2 things. I substitute my u squared, and I substitute my dx. So I get there is 2 over u squared plus 1 times du. Is this something on my pink sheet? kind of, except for the what? The 2. So what I do is I pull out the 2, and I say, this is my arctan formula. So it's 2, 1 over A, arctangent, U over A plus C. And so I substitute that in right here. This would be minus 2 over A, which is A just 1. Okay, so this is 1, this is 1. What's my U? X? Okay, so this will be minus 2. Where did I get the minus sign? Is it a plus? Yeah, I think it's a plus. Plus 2 arctan X plus C. Okay, are you guys comfortable with this problem? Okay. I'd like to move on, and if we have more time for homework later on, we could do that. But I'd like to move on to make sure that we cover what we need to cover. So let's look at your guided notes today. Okay. And I've talked to you about this before, but on your quiz, this problem is for sure. Number 2 is for sure on your test, okay? So if you have trouble with that, redo it. Make sure that you can do it. Lots of people around you have the answer. Okay, so talk to them about it. Okay? And again, I'll be here after school. Okay, so what we're going to do today is we're going to talk about problems when you have sine and cosine, the integral sine and cosine next to each other. Okay? Or even if you have one and not the other. What will you do? Okay? If it's not easy to do. So if you can't do it with simple U substitution, okay, the rule goes like this. It's a strategy. Okay? You look at your exponents and say, do you have any odd exponents? If you do have any odd exponents, okay, choose one. It doesn't matter which one you choose, okay? If it's like a cosine that has an odd, you keep one cosine and change everything else to sine using Pythagorean theorem, okay? If it's a sine that has an odd, it doesn't matter which one you choose if they both have an odd. If you choose the one with a sine that has an odd, you'll say, I keep one sine and change everything else to cosine using Pythagorean theorem, okay? That's your strategy. That's what's going to work for you. You just have to memorize the strategy, okay? If you have no odd exponents, okay, you only have evens, then what you do is you use these 2 formulas that you learned in pre-cal, okay? I know you learned them in pre-cal, okay? They look kind of weird, okay? But you'll memorize these formulas, and all you'll do is plug in if you have even exponents. The formulas come from your cozy, remember your double angle formulas and these formulas like this? Your cozy formulas. These, I did it here so you guys can see where it came from, but in the end, you don't really have to memorize these formulas. You just need to know the final result, okay? So on your pink sheet and also on your notes here, it has these formulas that you need to memorize if you're taking BC Calc, okay? And so let me do one problem with you. Let me do the first 4 problems with you guys, and you guys will see how these problems work. So we're going to go through your guided notes. The first problem we have is cosine cubed 5x dx. All right. So the first thing I say is, can I just do it with simple U substitution? Okay, I'm looking at this thinking I don't really know how to do it with U substitution. The x's aren't going to cancel out. And so what I do is I say, okay, it has an odd exponent. Okay, so if it has an odd exponent, I'm going to keep one of them. Okay, so take out one of them. If I take out one of them, do you see I have 2 left over? Okay, and this is the first step. And students who cannot do this step or don't do this step, okay, have a lot of confusion on their paper usually. Okay, so please don't take shortcuts. First, you guys say, I'm going to keep one, and what I have left over is 2 cosine. Okay, then the next thing you do is the one that you keep it. Okay, so I'm going to rewrite it. The one that you don't keep, you change it to sines. Now, how do I change cosine to sine? Well, I know that cosine squared 5x plus sine squared 5x is equal to 1. Right? You know that. So that means this cosine is actually equal to 1 minus sine squared 5x dx. Okay, that's what I did. Okay, then I keep one cosine, change everything to sine, which I've done. Then what I want to do is I want to get as many free as I can. Okay, it's just an agent thing. Okay, you buy one, get as many free as you can. Okay, but the thing is, essentially what that means is you just keep distributing until you can't distribute anymore. Okay, and then you'll end up with a buy one, get a whole bunch of free. Okay, so what I have here is this factor and this factor. So what I'm going to do is I'm going to distribute. So this becomes cosine 5x minus cosine 5x times sine squared 5x. I'm going to rewrite this actually as sine 5x squared dx. Okay? So all I did was distribute this. I really don't like this notation. I don't know who made it up with the squared coming in, but students don't treat it correctly. It really, what it is this entire sine 5x with the square on the outside. Okay, so I'm going to rewrite it like that. Okay, and so I look at this and I'm like, can I distribute any more? Okay, and that's pretty much it. You can't really distribute anymore. Like, I mean, what else would I distribute? That's it. I'm done distributing. Okay, so I have a buy one, get one free. Not bad. Okay, so what I'm going to do now is then I just integrate. Okay, so this is basically, if this makes any sense, two problems. Okay, so I'll just do them individually. What is the integral of cosine 5x? What's the integral of cosine u? Sine u divided by what? The derivative of u, which is 5. Right? So I'm already done with the first part. Okay? On the second part, I have a u substitution. Do you guys see that? So the u substitution is going to be u is equal to sine 5x. Du dx is going to be, the derivative of sine u is 5 cosine 5x. Dx is going to be du over 5 cosine 5x. I'm going to replace two things, substitute two things. I'm going to substitute my u and my dx. Okay, this is my u. So the rewrite is going to be cosine 5x times u squared times du over 5 cosine 5x. And so I ask myself the question, do my x's cancel out? Do they? Yes, they do. So what I have left is 1/5 times the integral of u squared du, which is actually 1/5 times u cubed over 3 plus Charlie. But my u is actually not u. My u is actually sine. So the answer is that sine 3? The answer is 1 over 15 sine 5x cubed. Everybody good with that? Okay. So my final answer is going to be sine 5x over 5 plus, no, actually not plus. This is a minus sign here, so it'll be minus 1 over 15 sine 5x raised to the third power, and don't forget Charlie. So there's my final answer. Okay, what I want you to notice is that I did a lot of work here, okay? And I could go astray. There are many ways I could go astray here. But if you're very comfortable with u substitution, keep it. But what I'm going to do now is I'm going to pull this into a pattern recognition problem, okay? And I'm going to show you that I get the exact same answer with a lot less work, okay? But of course, pattern recognition requires more intuition, so it's easy to make a mistake if you don't do it right. Okay, so here's my u, okay? You have to decide what your u is. Just like u substitution, you decide what your u is. Whatever your u is, whatever exponent is attached to that, that is your exponent. You don't get to decide your exponent. Once you decide your u, whatever is attached to that is your exponent. So what I do to the exponent is I add 1, divide by the new exponent, and don't forget to divide by the derivative of your u. Okay, this was the walking backward thing. Remember how we walk backwards? Okay, remember when we did chain rule? It was like, I actually don't remember, but it was like multiply by the exponent, then multiply by the exponent, multiply by the derivative of your u, and then subtract 1. Oh, subtract 1 from the exponent. Okay, let's do it again. Okay, so it was like multiply by the exponent, subtract 1 from the exponent, and then multiply by the derivative of your u. Okay, we're just walking backwards. Okay, we're going to add 1 to the exponent, divide by the new exponent, and then divide by the derivative of your u. Okay, so it's pattern recognition. So I added 1 to the exponent, divided by the new exponent, and divide by the derivative of my u. What's the derivative of sine 5x? 5 cosine 5x. Is that right? The derivative, right? And the derivative of sine, is it negative or positive cosine when I'm talking about derivatives? Positive, so I'm okay. Then you do your same thing. Do your x's cancel out? You cover your u, though, not counting your u. Do your x's cancel out? Yes, they do. And your x's have to cancel out, and if they do, then by pattern recognition, you can just copy down what you have left over, which is 1 over 3 times 5, which is 15, sine 5x raised to the third power. And don't forget Charlie. And did I get the same thing when I did u substitution? Yes. Okay, so I'm going to go into this period where I'm just going to not do u substitution just to save time. If you need to use u substitution, go for it, okay? But try to do it as fast as you can, because it'll be beneficial if you can do these things fast. All right, let's go to your next problem. All right, what I have is the integral of cosine 3x sine squared x dx. All right, so my strategy is, okay, first of all, just try to do it without, just do it with u substitution, okay? And it's actually too complicated to do with u substitution. So I want you to tell me, do I have any odd exponents? Yes, on which one? It's cosine. So what I want to do is save one cosine, okay? But if I save a cosine, do you see I also have left over two cosines? Okay, so you rewrite this, okay, with saving a cosine. Okay, now this is a cosine I want to save. Okay, so let me just write save here. Save that one. Everything else I want to change to sine. If I saved a cosine, I want to change everything else to sine. If I save the sine, then you're going to change everything to cosine. All right? So I'm going to change this to sine, and you're going to use the Pythagorean identity to change it. So that's 1 minus sine squared x times sine squared x dx. Okay? Everybody good so far? And then what I want to do is make sure I did it. I save one cosine, change everything else to sine. Then I want to get phi 1, get as many free as I can. Okay? But the way to do that is actually to distribute until you cannot distribute anymore. Okay? Now, students have problems distributing. The truth is you can only distribute one thing at a time. Okay? So I pick what I want to distribute. I mean, I can do this one and this one. Okay? I distribute this into this factor. But that's pretty much it. I can't distribute all three at the same time. It's impossible. Okay? So you pick two factors, and you just go ahead and distribute that. Okay? So this is going to be cosine x minus cosine x sine squared x. Okay, I still have this sine squared x here, but make sure you understand it. After I distributed this, okay, this sine squared x, it's now being multiplied by this entire thing, okay? So the calculus here, most students could do the calculus if they could do the algebra. Okay, the algebra here is where students get lost, okay? So once I distribute this sine squared x is actually being multiplied by this whole thing. And then what I have to do is, remember the point is distribute until you can't distribute anymore. That's how you get phi 1, get as many free as you can. So I'm going to take this sine squared x and I'm going to distribute it into these two terms. And so this is going to be cosine x sine squared x. I'm going to rewrite this as sine x to the squared minus cosine x. What's sine squared x times sine squared x? To the fourth. And there I am. And once again, it just takes practice on the algebra part. I feel like the calculus part you could get if you could just get the algebra part correct on there. All right. I rewrote all my sine x's. I did that on purpose because I'm about to do pattern recognition. Okay. Do you guys see that? I'm pretty much done distributing. I mean, I don't see another way that I could distribute that would change this. Into three buy one get one free. I mean, I just have a buy one and get one free. I don't see how I can get another one free. I mean, I'm trying, but I don't see it. Okay. So what I'm going to do is I'm going to say this is my u. Remember, I have two integrals now. This problem to do and this problem to do. Okay. Here's my u. If the sine x is my u, then that exponent is what I'm working with. So I'm going to add 1 to that exponent, divide by the new exponent, which is 3, and don't forget to divide by the derivative of my u. What's the derivative of sine x? Cosine x. Then I ask myself the question, do my x's cancel out? Do they cancel out? Yes. Okay. Not counting your u. Your u doesn't count, but everything else, do your x's cancel out? Yes, they do. So this answer is sine x raised to the third power over 3. And I'm done with one of the terms. Okay? Let's go to this term. This term, I'm going to pick sine x as my u again. Okay, that means my exponent is 4. I'm going to add 1 to the 4, divide by 5, and then divide by the derivative of my u. My u is sine x. What's the derivative of sine x? Cosine x. Do my x's cancel out? Yes. So what I get here, this negative sign is just being carried down. What I get is sine x raised to the 5th power over 5. Don't forget Charlie. And I'm done with this. Okay. You guys feel comfortable with that? Okay, so you'll get some practice tonight. And let's go ahead and go to the back side of your sheet. And we're going to talk about two formulas that you need to memorize. The first one is cosine x squared is equal to 1 plus cosine 2x over 2. Okay, that could be on a formula quiz. It's on your pink sheet. It's a formula you just have to memorize. Okay, the other formula you have to memorize is sine squared x is equal to 1 minus cosine 2x over 2. You see they're basically the same formula that you have to memorize. Okay, it's just that if they're both cosine, this is a positive. If one's sine, one's a cosine, then it's a negative. Okay, I need to point out to you this though. If this x were not an x, if this x were 3x, then what that means is this x right here is not an x either. That means this x would be a 3x. So what would this entire thing be? 6x. Okay, so just make sure you understand that if this number changes, then this number has to change also. Okay, so let's go ahead and do your first one here on the back. And see what is the problem. You have sine squared 3x times cosine squared 3x dx. All right, with these cosine and sine problems, first you got to try it and make sure that you can't do it, okay, with simple u substitution, okay? And then you're going to look at it and you're going to say, do I have an odd exponent? Is there an odd exponent? No, okay? There's not an odd exponent, so I'm not going to do what I did on the other two problems. What I'm going to do is I'm just going to substitute these formulas in. That's all you do for even exponents, okay? So sine squared is this formula right here. So you're going to do the integral of 1 minus cosine 2x, oops, it's not 2x, what is it? 6x over 2. Now, all I'm doing is substituting in the formula. What's cosine squared going to be? 1 plus cosine 6x over 2 dx. Okay. Now if I take the integral of this, then I'll get the integral of this. Okay. What I'm going to do is I'm going to pull out my scalar. I actually have a 1/4. I think it's just easier for me not to work with fractions, but if you want to leave it in, it's fine. Okay. And then up here, I don't know if you see it, but these are actually both quantities because this is the entire numerator and this is the entire numerator. And so if I multiply these two together, do you see it's a FOIL? I have to FOIL it. But there is kind of a pattern here. This is a minus b, and this is what? A plus b. So what's a minus b times a plus b? Do you remember? A squared minus b squared. Okay? So this is going to be 1/4 the integral of 1 squared, which is 1, minus cosine 6x squared, which is cosine squared 6x. Okay? Dx. All right? So what I want to do, just like I wanted to do before, is get a buy one, get one free as much as I can. Like basically separate them into as many different problems as I can. And this is pretty much separated. I don't think I can distribute anymore. But I do kind of have a problem. I don't know how to integrate with cosine squared. But wait, there's a cosine squared here. So what do you think I have to do? You do it again. Okay? This problem, cosine squared 6x, now just becomes 1 plus cosine 12x. You see that? So you're going to do it again. Okay? So this is going to be 1/4 times 1 minus. This right here is equal to 1 plus cosine 12x all over 2 dx. You see where I got that from? It's just the formula. You good? Okay. So now what I want to do is I want to divide this into as many problems as I can. And you'll just get good at this after a while. What you have to do with these problems is you have to divide this like a common denominator problem so that you can actually integrate it. So this becomes 1/4 times 1 minus 1/2. This negative distributes, so it's actually negative cosine 12x over 2 dx. Okay. And at this point, this is something that I can do. It's 3 different problems, but I can do every single one of them. As soon as you get rid of the squared on the cosine, then you can do these problems, okay? If you want, you can combine the 1 and the 1/2, or you can do it as 2 different problems. Do you want to combine it? What's 1 minus 1/2? Okay, so this is just 1/2 minus cosine 12x over 2 dx, okay? And really, this is a buy one, get one free problem, okay? There are actually 2 integrals here. This 1/4 gets multiplied by all of it, so just make sure you're done. You multiply one by 1 point when you're done. So let me hold the 1/4 on the side. What's the integral of 1/2? 1/2 x. You guys good with that? Okay. What's the integral of? Okay. So I'm going to pull out the scalar. If you guys can see it, this 2 is a scalar. So I'm going to pull out the 1/2. What's the integral of cosine u? Sine u divided by 12, right? Remember we talked about the shortcut for that cosine u? Sine u divided by 12 plus Charlie, but actually before I add Charlie, let me go ahead and multiply by 1/4, and I'm going to add Charlie. Actually, it doesn't matter. You can have a 1/4 Charlie, but that's kind of like, well, you didn't know what Charlie is anyway, so what's 1/4 Charlie? It's still some Charlie, okay? And this is a good answer. I would just ask you to combine the 2 times 12 to 24, but other than that, you could leave the answer just like this. If you wanted to distribute the 1/4, you could. You just kind of take a chance, you know, if you distribute it wrong, then it's wrong. Okay, you ready for the last one? The integral of 4 of these cosine x's. Integral of 4 of them. Okay, first question. Any odd exponents? No. Okay, so I'm going to go with the even formula. Even formula says everywhere there's a cosine squared, I'm going to change it to another formula. Do I have a cosine squared here? Do I want a cosine squared? If you want it, make it happen. Okay, I could split it up into 2 cosine squares. And I know what cosine squared is. Okay, cosine squared is 1 plus cosine 2x over 2. 1 plus cosine 2x over 2. Okay, I'm going to pull out the scalars at this point because that's just something I do. But if you guys don't like pulling out the scalars, it's not a big deal. Okay, and what I have here is a FOIL. It's similar to the last FOIL I have, but it's not an a plus b times an a minus b. It's actually an a plus b times an a plus b. So do you guys see that you're going to get a middle child here? Okay, so let's go ahead and FOIL this. It no longer has a denominator, so then it's going to be 1 plus 2 cosine 2x plus cosine squared 2x dx. Does that make sense to you guys? Did you guys get what I have? Okay, so what you're going to do now is, do you see you have a buy one, get 2 free problem? That's a great deal. You could actually make this a better deal. Do you see what else we need to simplify? Yeah, that cosine squared right there. Okay, so let's rewrite that. And what I have is 1/4 the integral of 1 plus 2 cosine 2x, okay, plus this cosine squared is now 1 plus cosine. Now, not 2x now, though. What is it? 4x all over 2 dx. Okay, I'm in pretty good shape. It's just that I'm going to have to integrate each one of these. And it's really hard to integrate 1 plus cosine 4x over 2. But if I split it up, it won't be hard to integrate. You guys see that? So if I split this up into 1/2 plus cosine 4x over 2, I'll be able to integrate it. But do you see, and again, you don't have to do this, but do you see you could combine the 1/2 with this 1 here? Do you want to do it? I don't really care.
Yes.
You want to? Okay, so I'm going to combine it. But if you didn't, you would just do 4 integrations rather than 3 integrations. Okay? So what I'm going to do, let me make sure I make this clear. I'm going to combine this 1 and this 1/2. Okay? So that's going to be 3/2 plus 2 cosine 2x plus cosine 4x over 2 dx. Do you feel like you could do it on your own? Could you take it from here on your own? It's a buy one, get 2 free problem, which is a pretty good deal that I got for you guys here. Okay, so I'm just going to integrate one at a time. Remember, guys, this 1/4 just kind of stays by itself. It'll be remultiplied by every single term in here. What's the integral of 3/2? 3 x. Okay, this 2, guys, make sure you understand, is just a scalar. So I'm going to pull that 2 out. I'm going to multiply it by the integral of cosine u. What's the integral of cosine u? Sine u divided by 2. Good. All right, and I'm going to do the same thing here. This 1/2 here is actually a scalar. So I'm going to pull out this 1/2. Okay, and I'm going to multiply this by, what is the integral of cosine 4x? Sine 4x divided by 4. Is that right, guys? Okay, and this is good. I would combine these, make that an 8. There's nothing else I could do. Don't forget Charlie. And if you wanted to redistribute if you wanted to distribute the 1/4, you could. I wouldn't recommend it. I'm good just the way it is. Okay. Any questions on how to do this? Okay.